Welcome to June 20th LeetCode Challenge. Minimum deletions to make character frequencies unique. A string S is called good if there is no two different characters in S that have the same frequency. Given a string S, return the minimum number of characters needed to delete to make S good. The frequency of a character in a string is the number of times it appears in the string. For example, you have the string AAB, the frequency of A is 2, while the frequency of B is 1. So the input, example number 1 here, we have the input of S being AAB, and we want to return the minimum number of characters you need to delete to make S good. S being good meaning there's no two different characters. So that means that there's basically nothing you need to delete in in this character here because S is already good, right? Because there's no two different characters in S that have the same frequency. As in A has a frequency of 2, while B has a frequency of 1. 1 is different from 2, therefore S is good. And we see the next one here. We see that A and B both have a frequency of 3, resulting in so if we delete B 2 times, resulting in the frequency of B of 1, therefore it becomes good. Because if we delete B once, it would be the same frequency as C, and if we delete it again, it has its own unique frequency. And that's pretty much the idea. So for this one, S, if we delete both C's, resulting in a good string, therefore we just delete about the strings only. So we don't care about the character that are still remaining in the string. So if we just delete a character completely, that's also a valid good string as well. But obviously we try not to resort to that if we don't have to. Find a good algorithm to delete characters. So the length of S is between 1 to 10 to the 5, and S only contains lowercase English letters. And there are some hints here because this is a medium question. Let's look at some of the hints. Delete characters, multiple characters having the same frequency. We must delete the frequency of them except for 1. Yes. Sort the alphabet character, and frequencies are non-increasingly. Okay, that's a good idea. We're going to sort it actually. Iterate through the alphabet character in decreasing frequency, and then until we reach a value that's not appeared before. Alright, so we're actually going to follow these hints here. So the thing we want to do is probably we're trying to solve this by sorting it first. So let's say if we found a duplicate element, we would repeatedly decrement it by 1, right? So say we found the frequency of A being 3, the frequency of B being 3 as well. That means we have to decrement one of them by 1, right? Until it becomes unique. We decrement B, for instance, because that appears second, and it's the same frequency as C, so therefore it's not unique, therefore we have to decrement it again. So it'd be more efficient if we could change to a unique number in just one step, right? We just do all one step instead of decrementing it. So if we know the largest unoccupied number that's less than the current number, we could store all the unoccupied numbers in a list that is less than the current number. So if we find a particular frequency x, let's say, we know what the highest number could be, so therefore anything below that that's available, then we just ideally put that number, delete the number specified or next spot allocated that will make the string s good. Meaning that we can find the largest, basically the largest frequency in the array s, and then we just find all the gaps that are below it. So therefore, if we find a letter that has the same frequency as the max, then we just decrement it by the next available smallest, the minimum number of characters we can delete from the next to make it s good. So we know that 3 is the max. Therefore, the next available will be, if we know 2 also exists, then the next available small character deletion we should make would be such that B has a frequency of 1. So therefore, we just delete 2 B's. So we just know right away which frequency we could automatically assign the duplicates to. So, alright, that's an idea. So however, there's not a very space efficient way to do that because we need to store all the possible frequencies with the scales, the string, and the length as well. So one of the ideas is that we have to store all the numbers. So we can actually circumvent this by having a list of unoccupied frequencies by iterating over the frequencies of descending order and keeping track of only the maximum frequency that is allowed. So remember that each frequency, if it is unique, then we want to keep it as it is. If it's not unique, then we decrement it as low as possible. Therefore, we know that the maximum number of frequencies that can be converted then can simply be changed into duplicate frequency of the values, decrementing frequency one step at a time. So this approach kind of iterates through. I'll kind of type out a bit of the code and just explain the rest. So say we have a frequency, call it frequency. Actually call it frequency, and that's going to be a default dictionary of integers. So for character in S, we want to find the frequencies. So we have to iterate through the frequencies in descending order. Before we iterate through the elements, we would have to have the maximum frequency that the number can be converted to. So the maximum frequency is the maximum number of possible numbers that is not occupied yet. So meaning that we have to frequency of the character to be decremented by 1. So that's all we would need to do. If the maximum frequency is greater than or equal to the frequency we consider, then we don't need to delete any characters. If the frequency is, I'll just kind of go over that in a bit later. So we have to iterate through it, find the maximum number of frequencies that are allowed or possible. The next thing you want to do is sort the array, sort the frequencies. So let's call this call it sorted. Nope. Sort. Call this. Call it array, I guess. And we're gonna sort it using the frequency dot values by value, I should say, in reverse order. So in decreasing order. True. So next thing we want to do is have an output, which is keep track of our count. We have a visited set. This is going to store the set of the things we visit. So for, let's say, frequency f in our array, we want to, while the frequency is visited, so we've seen it before, and the frequency is greater than 0, meaning that if the frequency allowed is greater or equal to the frequency of considering, then we don't need to delete any characters. If the frequency is considered greater than the frequency allowed, then we need to delete characters and add the number of deleted characters to the count. Right? After each step, update the maximum frequency. So we're going to update the frequency, decrement the frequency count by 1, update the count output by 1, and then by 1, I should say. And then visited will be adding the frequency to the array. So we don't visit again, return the count. Mid output. So after each step, we would update the maximum frequency allowed and to be 1 less, and the frequency used in the last element as well. So that's kind of the idea between this. So let's run this code. Alright then. Let's see what the deal is. So there we go. Oh, in, what am I doing? Oh, this is also in as well. Let's run that again. Submit. Accepted. So the time complexity is actually so we traverse through the string, which will take big O of n times, right? As such for this for loop. We also have the sorted algorithm, which it runs in big O of n log n frequencies as well. So big O of n essentially, or actually big O of n plus big O of n log n, or k. Space complexity, we store everything inside a set, and set is of the size of the frequency. So therefore, unique frequencies, I should say. So be big O of so it depends on, let's see, we also use the default dictionary. So big O of n, right? Where n is the size of the default of the frequencies that are unique, and it will actually be less than n. So it will be some kind of constant. Alright, that's it. Have a great day.